One moment, a fishing village sits peacefully along the eastern Visayas coast. The next, a wall of water 5 meters high crashes over the seawall, swallowing homes, boats, and everything in its path. This is not a tsunami. It's something far more common and just as deadly. Scientists say the most dangerous storm surge and wave conditions in years are building right now across Philippine coasts. Why do these monster waves strike without warning? And what happens if you ignore the alerts? From November through December 2025. The Philippines has been battered by a relentless series of super typhoons and tropical storms. Typhoon Kalmaegi in late October killed at least 269 people, left 523 injured, and 113 missing, most of them in Cebu. The destruction was so widespread that President Marcos declared a nationwide state of calamity on November 6th. Just days later, Super Typhoon Fung-wong, locally known as Yuan, slammed into the eastern coast with winds exceeding 2. And now, in early December 2025, Tropical Depression Wilma and the enhanced northeast monsoon have triggered renewed flooding across Mimaropa, Regions 5, 7, 8, and Caraga. As of December 8th, over 132,000 individuals from 57,600 families have been affected, with 22,700 people displaced and 13,900 sheltering in 102 evacuation centers. The Philippine Coast Guard has suspended sea travel at 86 ports nationwide, stranding over 6,600 passengers, crew, and cargo staff. Coastal communities are facing not just rain and wind, but the terrifying combination of storm surge, monster waves, and king tides that can turn a familiar shoreline into a killing zone in seconds. What makes these waves so dangerous is not always their height, it's their power and unpredictability. During typhoons and enhanced monsoons, the Pacific Ocean becomes a generator of long-period swells. These are waves that travel thousands of kilometers from deep offshore storm systems, building energy with every mile. Unlike the short, choppy waves created by local winds, long-period swells arrive in massive sets with intervals of 15 to 20 seconds or more between crests. Each wave carries exponentially more energy than normal surf. When these swells reach shallow coastal waters, they slow down, compress, and suddenly grow taller, releasing all that accumulated force in a violent surge that can sweep far beyond the normal high tide line. PAGASA, the Philippine Atmospheric, Geophysical, and Astronomical Services Administration, uses sophisticated monitoring systems to track these conditions. Coastal weather stations, tide gauges, and offshore buoys measure wave height, period, wind speed, and barometric pressure in real time. When storm systems intensify over the Pacific, PAGASA issues storm surge warnings, alerts that specific coastal areas could experience life-threatening rises in sea level, sometimes exceeding 3 to 5 meters above normal tide. These warnings are not guesses. They are based on decades of typhoon data, computer modeling, and direct observations of atmospheric and ocean conditions. But here's the terrifying reality. Even with warnings, people die. During Typhoon Kalmaegi, hundreds were killed, not just by wind or landslides, but by floodwaters and storm surge that caught communities off guard. When Super Typhoon Ragasa struck in September 2025, with winds exceeding 267 kilometers per hour, making it the most powerful storm on Earth, that year entire coastal barangays were submerged under walls of water driven ashore by the typhoon's fury. And during Typhoon Fung-wong in November, giant waves battered the eastern seaboard, destroying homes, collapsing sea defenses, and forcing mass evacuations across multiple provinces. The storm surge phenomenon is amplified by several factors. First, typhoons generate extreme low pressure at their centers, causing the ocean surface to literally bulge upwards, sometimes by a meter or more. Second, the powerful winds circling the typhoon push massive volumes of water toward the coast. Third, When this surge arrives during high tide, the combined effect can raise sea levels to catastrophic heights. And fourth, long-period swells generated far offshore arrive simultaneously, adding wave after wave of destructive force on top of the already elevated sea level. Imagine standing on a beach in Catanduanes as Typhoon Fung-wong approaches. The sky darkens, the wind howls, you see the waves growing 10 feet, 15 feet, 20 feet, 20 feet crashing with a roar that drowns out every other sound. Then the storm surge begins. The entire ocean seems to rise, pushing forward like a living wall. Sea walls that have stood for decades are overtopped in minutes. Homes are ripped from foundations. Fishing boats are flung inland like toys. And anyone who waited too long to evacuate is now fighting for their life in churning, debris-filled floodwater. The Philippine Coast Guard, working alongside local disaster response teams and the armed forces, operates under full alert during these events. They conduct search and rescue operations, enforce evacuation orders, and suspend maritime travel to prevent vessels from being caught at sea during peak conditions. But their ability to save lives depends entirely on people heeding warnings early. The deadliest mistake is waiting to see how bad it gets. By the time you see the monster waves, it's already too late to escape safely. Let's talk about the science behind what creates these conditions. Far out in the Pacific Ocean, deep low-pressure systems form during the typhoon season, which typically runs from May through December. These storms are fueled by warm ocean water. Sea surface temperatures above 26 degrees Celsius provide the energy needed for rapid intensification. When a tropical depression strengthens into a tropical storm, and then a typhoon, the winds around its center can exceed 200 kilometers per hour in super typhoon cases. The strongest storms, like Ragasa and Fung-wong in 2025, can sustain winds over 230 kilometers per hour, equivalent to a Category 5 hurricane on the Saffir-Simpson scale. As these typhoons move across the open ocean, their winds generate waves that radiate outward in all directions. The stronger and more sustained the wind, the larger and more powerful the waves become. This process, known as wave generation, depends on three factors: wind speed, wind duration, and fetch, the distance over which the wind blows without interruption. In the vast Pacific, fetches can extend for thousands of kilometers, allowing waves to build into massive swells that carry their energy all the way to Philippine shores. When these swells approach the coast, they interact with the seafloor. As the water depth decreases, the wave slows down, but its energy is compressed, forcing the wave to grow taller. This is called swelling in shallow bays, estuaries, and near coral reefs. The effect can be dramatic. Waves that were 3 meters high in deep water can suddenly surge to 5 or 6 meters as they reach the shore. Add storm surge on top of that, and you have a recipe for catastrophic flooding. The 2025 typhoon season has been particularly brutal for the Philippines. Tropical Storm Wifa in July enhanced the southwest monsoon, triggering floods that affected over 9.5 million people and displaced nearly 200,000. Super Typhoon Ragasa in September was the most powerful storm of the year globally, grazing northern Luzon with Category 5 strength and forcing massive evacuations. Typhoon Kalmaegi in late October left a trail of death and destruction across Cebu and other central islands, prompting a nationwide state of calamity. And Super Typhoon Fung-wong in November displaced over 1.1 million people, killed at least 4, and left entire provinces without power for days. December brought little relief, as Tropical Depression Wilma moved across the Visayas and the northeast monsoon strengthened. Flooding returned to regions still recovering from previous storms. Roads remained impassable. Evacuation centers remained full, and coastal communities watched nervously as PAGASA continued to issue storm surge and high wave warnings. For those living along Philippine coasts, especially in eastern Visayas, Caraga, and Mimaropa, understanding storm surge and monster waves is not academic. It is survival. When PAGASA issues a storm surge warning, it means the ocean will rise significantly above normal levels. A 3-meter storm surge means the water will be 3 meters higher than usual at high tide, enough to submerge entire ground floors, flood streets, and turn low-lying areas into lakes. A 5-meter surge can overtop seawalls, destroy coastal infrastructure, and drown entire barangays. But storm surge alone is not the only threat. Waves ride on top of that elevated sea level. So if there is a 3-meter storm surge and 2-meter waves, the total water level can reach 5 meters above normal, enough to strike the second story of buildings. And because these are long-period swells with immense energy, they don't just splash, they crash with the force of moving cars, capable of breaking through walls, sweeping away vehicles, and pulling people into the churning water. The Philippine Coast Guard and local disaster risk reduction offices repeat the same life-saving advice every typhoon season. Evacuate early, stay away from the coast, never underestimate the power of water. Yet every storm, people die because they ignored warnings or delayed evacuation. Some return home too early to check on property. Others believe their houses can withstand the surge. And tragically, many simply don't understand what a 3-meter storm surge actually looks like until it's too late. The psychological challenge is real. Filipinos have lived through countless typhoons. Many coastal communities have developed a kind of fatalism, bahala na, or we've survived before. We'll survive again, but climate change is making storms more intense. Warmer ocean temperatures fuel stronger typhoons. Rising sea levels mean storm surges reach farther inland. And the combination of more frequent intense storms with less time to recover between them is overwhelming communities and disaster response systems. For those watching this video, especially if you live in storm-prone areas, here are the facts you need to know. First, always follow PAGASA bulletins and local government evacuation orders. PAGASA operates a comprehensive monitoring network that provides real-time data on typhoon location, intensity, track, and expected storm surge levels. Second, understand that storm surge and monster waves are not the same as tsunamis. They are weather-driven, not earthquake-driven, but they can be just as deadly. Third, prepare an emergency go bag with essentials: water, food, flashlight, first aid kit, important documents, and a battery-powered radio. Fourth, know your evacuation routes and designated shelters before a storm arrives. And fifth, never wait until you can see the waves. By then, it's too late to evacuate safely. The 2025 season has already claimed hundreds of lives and displaced millions. Typhoon Kalmaegi, Fung-wong, Ragasa, Wilma, and the enhanced monsoons have battered the Philippines from north to south, leaving communities in ruins and families grieving. As December progresses and the northeast monsoon continues, coastal areas remain under threat. King tides, persistent swells, and the possibility of another late-season storm mean the danger is far from over. The ocean is not our enemy, is the source of life, livelihood, and beauty for millions of Filipinos. But during typhoons and enhanced monsoons, the ocean becomes a force of unimaginable power. Respecting that power, heeding warnings and evacuating when ordered, is not cowardice, is wisdom. Because no house, no possession, no stubborn pride is worth dying for when monster waves and storm surges come ashore. Use this quiet moment to get ready so you're not learning during the worst seconds of your life. Subscribe to BayanTube now. Turn on the notification bell and stay ahead of the next quake, wave, or eruption. Every video here turns fear into knowledge, and knowledge into survival. Stay safe, stay informed. And when PAGASA issues a warning, listen, your life may depend on it.